Hey friends, this is Quest and Current, and today I'm going to show you a USB cable that, while formerly being a Type-C fast charging cable, I'm quite sure that it officially or unofficially was made to be used inside a machine or an appliance prototype to be used to connect two of these internals together. So, for example, if you build a device which has a Raspberry Pi and a display and you want to connect both USB-C connectors together, you use a cable like this, and this one has one 90-degree angled connector and one straight connector, but theoretically they should work the same way, and you just mingle it in between in here, somewhere where you have space inside the case of your device, and then you use it from the outside like it would have been a singular unit. And so you save yourself the time to manufacture a PCB, to have some adapter board like that one, and can use this flexible one. But what I bought it for was not the fact that it is quite soft and definitely silicone, at least to its feel, but due to the fact that we can see each single conductor that runs inside the cable. So there is not a lot of magic going inside, because as you can see, the USB-C connector is directly soldered onto a really small PCB with just one component on, and then you have 5 pins which are soldered to the cable, and it is identical on the other end, just with this 90-degree angled connector. And it's really interesting that they used, and you can see it here if I zoom up a bit onto the USB-C connector on the back side. Yeah, I can get it in focus, nice. They used a fully featured USB-C connector, so you can see all the 24 pins plus shield that go inside the PCB here, while they actually only use 5 of them, and the 5 of them they use I'm going to explain in a minute. But there are connectors that are not fully featured, so you could have used a connector that doesn't feature the full 24 pins plus shield, but just some of them, just the most important one for example, USB 2 speeds or just for power delivery only. So the pins that are connected are even written on, I think, this PCB here. If I can focus onto here, I can. You can probably read it earlier than I can, because I'm only watching it on a really tiny screen. So it says GC plus minus and V plus. So that most certainly is ground. One of the CC pins, CC1 or CC2, plus minus, so D plus and D minus of the USB 2 protocol, as well as the V bus and V plus connection for V bus for the supply voltage, which they interestingly enough use the white marked end on this cable for, which is normally in case of capacitors customary to be the ground and not the V plus. But what they also used on both ends is one of the two connections on here. So it says C1 and C2, but only C1 is soldered. And I'm not sure why they used it and what they used it for, because normally in USB-C to USB-C cables there is no such capacitor inside, and you only have capacitors if you have power delivery negotiations going on and need a capacitor for your eMark IC. But what they did is they put a really tiny, I'm quite sure it's a 0402 capacitor on both ends of the cable. So they did have some special application for that in mind. And we are going to take a look what kind of capacitor it is and where it connects to in a second, once I find my multimeter. Give me a second. So I found my multimeter and I directly put it into continuity mode, so you can hear it beeping, and I will remove the tips from here so we can actually probe the connectors themselves. And let's take first a look at the straight connector, and I'm going to focus down on here if it focuses. Yes. So we're going to take a look at the cable end and where the capacitor is actually connected to. So let me first hold on to this capacitor here. I'm not sure if you can see it, but I can see it definitely. I'm going to put it on the left hand side of the capacitor, and oh, okay. So it was right the first connection I made, which is, if we take a look at the connector DV+, so one side of the connector the capacitor, I'm really sorry, is connected to V+. And if we take a look at the other side of the capacitor, then I'm most certainly it is going to be connected to the ground. Yeah, it is. So this capacitor is just a straight connection between V+ and ground. So it is in there to smooth out the voltage supply from this power supply that you connected to, or from the input and output side. The USB-C cable itself is bidirectional, both in power and data transmission. So this capacitor, and I'm quite sure that the other one is going to be the same. Let me first take a look if I'm not talking bullshit, so you can see it here. Yep. So one end is again ground, and the other end, stop beeping. Yeah, and the other end is V+. So both ends are actually supplied with the capacitor, and both ends of the cable are actually buffered with this little capacitor. So if you use them to connect devices internally inside your case, you do have some additional capacitors. I'm not sure what they initially thought to be using with those, but they did build it in that way anyway, and they only assembled one of the two capacitors on both sides of the cable. The last thing we're going to do, and for that I'm going to zoom back out again, is test the cable if it's actually what I said, a regular USB 2 cable with the D+ and D-, as well as the V+, V-, and one of the CC pins connected. And let's take a look while it's measuring. Yeah, so it says 0.48 gigabits, 480 megabits. This means USB 2 speeds, the charging power of 15 watts. So there's no e-marker I see inside that can do some power negotiations, which would have been surprising, to be honest, because we can see the PCB itself. And it is quite new, so the cable health is at 100%. Yeah, so USB 1 and 2 speeds at voltages 5 volts up to 20 volts nominally, with the USB-C spec and 3 amps. And the USB connector, if we take a look itself, is just the ground connections, the V+ connections mirrored again on both sides. So you have the current handling capabilities, as well as D+, D-, and one of the CC pins. And it is in this case, if we take a look at the details, CC1. So what we can see here is that CC1 is connected, but if we flip the connector around, it's going to be CC2, so it doesn't matter anyway. The V-bus resistance is at 98 milliohms, so it's quite a short cable, and the conductor thickness seems to be okay, as well as the connector plating, which is most certainly gold or some really good metal or alloy. There is no e-marker inside, so that's what we can find out about the cable itself. And if you ever, this connector is quite tight, so it definitely is supposed to be connected inside a device or inside a case and not get loose on its own, so it's a really tight connector. But with this, you now know that you can also buy internal USB-C cables, and you know what to use them for. And if you have any questions, just put them in the comments below. Thanks.